Okay, I'm back with a video about domain. So I've written some stuff out here for you, and I'm going to walk through it with you, so that you can kind of understand what's going on. First of all, domain is really just talking about all possible x values that a function or a relation can have. So when I say that it's talking about the x values and I underline that, that means that we care nothing about the y values. And that's because we're just talking about domain. So if we're talking about something else other than domain, that has to be asked for, or said find something else other than the domain. If it just says domain, then your only objective is to think about what are the allowed x values. Okay, so let's start with a simple example with ordered pair. So I've got some sets of ordered pairs right here. So right here, if you're given something that looks like this and asked to find the domain, well, all you have to do is look at the x values, 1, 4, 8, and 1, and you're going to write them in some kind of a set like this. Now, a couple of things with this. First of all, I've got a 1, 4, 8, and 1. Those are all of my x values, which is of course what we're concerned about with domain. But you may have noticed that I didn't write the second one in here. I only wrote one of them. And that's because with domain, you don't want to have repeats when you list your x values for the domain. So if you have a couple of ones here like I do, you're only going to write it once when you're actually writing the domain out. Another thing, you notice that I wrote this in ascending order, 1, then 4, then 8. That's not necessarily required. You just got to check with your teacher, see what is being asked of you there. But with domain, you can write it in any order that you want. Biggest thing is don't repeat x values. Okay, so we're going to look at two cases that kind of make domain a little trickier. First case. When you have a function in the denominator. And this is important because you don't want the denominator of something like this to go to 0. Okay, so when you have a function, looks something like this, I'll call it function of x. You do not want f of x to go to 0 in the denominator. It's okay if the top is 0. So we're trying to find the domain of this. That's the same question that we had for this stuff up here. It's just now being asked of us for this function. We're still just trying to figure out what are the allowed x values. And the way that we're going to do this is say, well, everything is allowed in an x value except for the stuff that makes the denominator 0. Okay, so to find out those numbers that make the denominator 0, or we could say that we don't want, I'll show you how to do that. This is how we're going to set this up. I need to make sure that the denominator, which is represented by x squared plus 5x plus 6, I need to figure out when this denominator is equal to 0, and then when I write my domain, I'll have it as these are the values that I do not want. So that's why I've written this as x squared plus 5x plus 6. I don't want these equal to 0. So we're going to solve this as we would if I just had a regular equal sign here instead of not equal, and see what we come up with. Okay, I notice this is a quadratic that I can solve using what I would like to call guess and check. You can use a variety of methods to solve this quadratic. Xbox if you want. But this one's pretty straightforward because I noticed that if there's two numbers that add to 5 and multiply to 6, well, that's 2 and 3, 3 and 2. However you want to write it is fine. So this can be written as x plus 2 times x plus 3. And these are the values that I don't want in my denominator. That's why I've set this equal to not equal to 0. There we go. Okay, so by the zero product property, because these two things are being multiplied and they're sort of set equal to 0, they would be if I didn't have the line going through there, I can use the zero product property to write this fact. X plus 2, I don't want it equal to 0. And x plus 3, I don't want that equal to 0 either. Okay, so this gives me two values that cannot be in the denominator of this function for the domain. So the way that I can write my domain, there's a lot of complicated ways that you can represent the domain once you arrive here at this point. For right now, you can just say the domain is all real numbers, and we figured out that the only real numbers that will not work for this domain are these two right here. Forgot the negatives. Okay, so I don't want x to be -2, and I don't want x to be -3. So accept x equals -2 and x equals -3. Those are the values I do not want to have x be, because then this denominator will be 0, and I'm not allowed to have 0 in a denominator. It's going to ruin the domain.